Do the thing! We are behind already. Do the thing! Hmm?
I remember kind of understanding. Okay. Because Rachel was texting me about it. I was listening to the third hour video.
All I can think of is saying he really dropped the ball. Like if you get it because of that, that's hilarious.
Celebrate Thursday, Fine Art Booster celebration this Thursday night.
It's kind of hard to do the thing if you don't have your stuff out.
Great day.
What does that mean? That inches?
Yeah. Can I give you all your quiz 7 and 8 back? I did for third hour. There we go. Okay, Jacob is gone. Isabella, Maddie, Ridger, Kate, gone today. Cadence, Rachel, Chase, Connor. Yeah. Owen, Riley. Levi, Lori, Holly, Summer.
Wow, one.
Hey, there's no question marks on this one. I'm proud of that.
Ah.
Why don't you Oh, wait, no, that's my own
You
question.
forgot.
Remember, if you define it to start in standard position. That's why it says in relation or relative to the ball. There was a lot of people on that expansion. For the logarithm expansion, there was a lot of people who missed the really basic part of like 6 becomes log of 3 and log of 2 or whatever it was. There was a lot of people who missed that. Okay. I take this to mean we are done with this part. No. Zoom, zoom. Zoom, zoom. Yeah, it's an old, was it BMW or Audi had a commercial that was, it was this little kid going zoom, zoom all the time. And I don't know, it was a thing like 20 years ago. It's the whole like European expensive high class art vibe, like perfume ads. I don't get it.
A base BMW 3 Series costs as much as the high-level Kia Soul.
I drive a Kia Soul.
Yeah, but the Kia Soul had little like rats inside the toaster oven box for their commercial, and that's funny. They're like bumping. They had like little running lights underneath the car, and it was adorable. All right. If robo arm starts here with ball, rotates 150 degrees, robo arm now here. And because it says relative to the ball when it's picked up, that means I get to just start it at initial standard position for any circle. Makes life a little easier. So if this is 150, that means my reference triangle is going to be 30, And a 30, 60, 90 triangle has ratios of 1, 2, square root of 3. But relative to where I started, what quadrant would I now be in? Second quadrant. So what do I have to change about those values? Square root of 3 got to go negative. Then I set up a proportion. If the radius is normally the 2 spot, but now it's a 15-inch arm, then I have to know in the 1 spot and the square root of 3 spot, negative square root of 3 spot, what will the other values be once I change that? Now, I could set up the proportion and Jesus fish those, right? Put X here, Y here. Or, if I just put 15 right here, I can use those, remember it was hypotenuse to short leg to long leg, little cheaters that we went through last week. If I go from 15, the hypotenuse, to the short leg, what do I normally do? Divide by 2, which is the same as multiply, divide. I would get 15 over 2. Normally, it's a terminating decimal, so I'll accept it. Multiply these two, I will not accept that, and divide by 2, or I take the short leg and multiply it by root of 3 to get over to here. So I'll have a negative 15 root of 3 over 2. So whether you're going to set up the proportion or you're going to use your old conversion, what do I do, multiply or divide, to go between the different sides of a 30, 60, 90 triangle, whatever you're doing, you should end up at a negative 15 root of 3 over 2, 15 over 2. Now I would prefer that as opposed to having a simplified radical and then the decimal 7.5, because now you're just kind of, I don't know. I mean, maybe you like fusion restaurants. Maybe you want to do sushi with spaghetti, but that just feels weird to me, to have the simplified radical for X and then a decimal for Y. Okay? Down here, you can just nicely look at your unit circle. All right? What I'm looking for here is some sort of work, your X and your Y coordinates. For these two, it's just simply, did you get it, yes or no, because you get to look it up. Now that we have the unit circle, we got the cheat codes. Cosecant of negative 4 pi over 3, negative 4 pi over 3, well, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Cosecant is reciprocal of what? Sine. And since the sine value is square root of 3 over 2, the cosecant is reciprocal of that, or 2 root of 3 over 3. Get back here. Cosine of 11 pi over 4. 11 pi over 4 is not on my unit circle. But if I take away 8 pi over 4 to find its coterminal angle, now I can just go to 3 pi over 4, look up my cosine value, and it is square root of 2 over 2 negative, because I'm in that quadrant. Okay? So 3 for the first one, because that involved a little more thinking. And then these are just straight up, I can look those up. Okay? Questions about it. Is there anyone who did not pick up one of the practice runs. Okay. If you want the practice run, what? Yes.
Kid yourself.
Yo.
I keep mixing these up in my head. I think I wrote it wrong in my notes.
No, that's right.
This is?
Yeah. Holly, you'll need the big stapler to do the big staples. Now put them all together, the whole packet. This is Big Kahuna.
I can do the because I'm using one of them as staplers.
No.
Is this what the actual?
Yes. You gotta fill it out.
I can do it. That's so nice.
All right. Oh, y'all gonna have to bear with me. I'm gonna sound like I'm 13 years old today. You ever done the whole like primal scream thing? Where you just let it go. Scream as loud as angrily as you possibly can. If you do it enough times, you kind of shred your vocal cords. And I sound halfway between a frog and a squeak toy today. So we started talking about these. We didn't have any assignment because it was, hey, look, I have the unit circle now. The unit circle is just the cheat codes for everything we've been doing anyway. But once we get the idea of a unit circle, that it is cosine, comma, sine, because those are the horizontal and vertical or x and y values when I'm dealing with triangles. The unit circle is just all of those triangles on repeat, and we start to get the periodic nature of those things, that they're just going to repeat themselves over and over and over and over and over. We started talking about the period of a function. It's how long does it take to repeat itself. And we said that the period is going to be 2 pi divided by b, meaning if it has a period change, a horizontal dilation, then okay, that'll change, but we start with 2 pi. We also found that the relevant features of these things will occur at 1/4 of the period. Maximum, intercept, minimum, intercept. So in that periodic function, it's going to keep repeating itself, these 4 aspects. So as long as I know what the period is, I divide that by 4, and I know where these features happen. Now, all the other stuff happens. This is pi over 2. Right here at pi over 4, it is hitting square root of 2 over 2. Right here at pi over 3, it is hitting square root of 3 over 2. At pi over 6, it is hitting 1/2. Okay, it is going to hit those values. It's just as long as we curve in between the extrema, I don't need to keep doing those. I can just find these 4 values and call it good. Okay? So I think we did one of these. Question mark? Where, make big. There we go. So the idea behind it was they're going to want 2 periods of function. You can either go from 0 out to 4 pi, because that's 2 laps around the circle, or you can go from negative 2 pi to 2 pi, still 2 laps around the circle. I like doing that because it shows positive and negative iterations of it, and we have dealt with positive and negative angles. So from negative 2 pi to 0 to 2 pi, the relevant features of a sine or cosine graph are going to happen at 1/4 of the period. So if the period's 2 pi, cut it in half, or sorry, in fourths, and get pi over 2. So each box counts by pi over 2. 0, pi over 2, 2 pi over 2, reduce, 3 pi over 2, 4 pi over 2, reduce, and their negative counterparts. The amplitude of these things changes depending on that a value in front of sine or cosine. The first two that we're dealing with are, what did we do? Y is sine of x, and then the other one would be probably 1/2 or 1/4. Well, 1/4. Those are pretty typical things. So if I want both of those on the same set of axes, I want to make sure that my vertical axis can fit an amplitude of 1 and an amplitude of 1/4. So, customary to put your big one at the ends of the scales so that we can say here's a half, here's a half, half a box. Half of a box, when each box is already a half, is now 1/4. So, sine of x. You start by looking at the circle, and you're going to get real used to this. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. Sine of 2 pi is 0. And it does this dance of middle down, middle up. Middle down, middle up, middle down, middle up. Put it on auto tune, you'll make millions because you're just repeating yourself. So, connect the dots. Try to keep it curvy. It should not look like a heart rate monitor. Okay? Try to keep it curvy. And then when we do 1/4 of that, nice and simple, it's just the amplitude is going to be to 1/4 instead of 1. Because 1/4 of 0 is still 0. 1/4 of 1 is 1/4. 1/4 of 0 is still 0. Is 1/4 is 0. Is 1/4 is 0. Is 1/4 is 0. Connect the dots again. Try to keep it curvy. There you go. And you can literally see that amplitude change. A couple things we're going to talk about today: amplitude, period, phase shift, vertical shift, frequency. Now, I know your generation has primarily grown up with streaming services. Do you at least know what AM and FM radio are? Do you know what it stands for? Amplitude modulation versus frequency modulation. They are literally, amplitude just pumps more power into the signal they're sending out. More power means greater amplitude. Frequency modulation means, you know, the inside of every radio, well, old ones, not digital ones now, had little coils. And those coils, the distance between them would catch the frequency of the wave as it hit it. So, everyone ever been in an old vehicle where he's got an old style radio and you literally just crank the wheel back and forth to change the radio station? You are physically changing the compression on a coil in the radio, so that when it's this big, the distance between those coils matches the frequency of that wave. Okay, so that's how all this stuff happened. Frequency, amplitude, all these words that you've heard since probably middle school or physical science. Oh, do they do things? That was a sine. Let's do cosine. I'll do 1C, and then we'll have you do the other ones. Regular and 2, make big. No, that's got a 1/3 on it. We just did a 1/4. We've already done a sine. I want to do a cosine. So we got regular old cosine of x, and then we'll have its buddy 2 cosine of x. I don't see anything next to the x, so it hasn't changed the period. The period is still 2 pi over b is 1 right now. So it takes 2 pi, 1 full revolution, for these to repeat themselves. I will label my axes accordingly. From 0 to 2 pi, and from 0 back to negative 2 pi. Because the period is always 2 pi over b, the period of both of these is going to be 2 pi. The relevant features of a sine or cosine graph, called sinusoidal functions when you put them together, is always going to be a quarter of the period. So take 1/4 times 2 pi, I get pi over 2, which should make sense for us. Those are the quadrantal angles. Going to be 1 pi over 2, 2 pi over 2, 3 pi over 2. Negative compatriots. So all I'm doing is labeling my axes. Are we cool with that part? All the ones we're going to do for the next couple are going to be like this. I'm not going to mess with it yet. Okay? Big yet. Then, my vertical axis. Which of these two has a larger amplitude? Okay, so I need to make sure that my graph is going to fit both of these functions. So I'll make my scale go by 1 and 2, -1 and -2. Then, where does cosine start? What is the cosine of 0? 1. So, the cosine of 0 is 1. What's cosine of pi over 2? Zero. Cosine of pi? -1. Cosine of 3 pi over 2? Cosine of 2 pi? 1. Do you see that oscillation? Okay, between maximum, midline, minimum. Up, middle, down, middle, up, middle, down, middle, up. Yes.
So when sine, like between 0 and pi, that was like 1 period, right?
No, that was half a period.
Yeah. So is that the same thing for cosine?
1 period is from 0 to 2 pi. You are going to see all the way from maximum to minimum in a 1 pi stretch. It's going to take 2 pi to restart the cycle. So, now it does right now look like a big W, but what would happen if I were to take this exact same thing and just shove it over pi over 2? It's sine. Okay? Cosine is a 1/4 period, or pi over 2, translation of sine. Okay? It really does look like that logo, doesn't it? The Wonder Woman logo. Okay, how do I change it for round 2? Twice as tall. Up, middle. Down, middle, up, middle, down, middle, up. No. Although I wouldn't put it past the goof troop in the back.
I don't
Was that a challenge?
No.
You're at 9 out of 10. Okay. So far, everything that we've done is going to have the same x-axis. Negative 2 pi to 2 pi, pi over 2 increments. Sine and cosine are always going to look the same. You just have to change your vertical axis to match the amplitudes available. Okay? They also just look really cool.
Pause. No, I just wanted to know what you do. I was talking about.
A and B go.
I let Lori just.
A and B go.
Oh, where did you check my I took the key.
Can you really afford to miss class like that?
No.
I don't understand 1/3. Like, what the heck is that? I don't know.
The amplitude is 1/3.
I know, but.
So instead of going up to 1 and down to -1, it's going to go up to 1/3 and down to negative 1/3. How are you going to change your axis to show that?
Polar Express is such an amazing movie.
The eyes are really freaky though.
That's besides the point.
It looks like Mark Zuckerberg.
That man.
I like this game. Like the coloring book.
Connor, do you see any coloring books he's going on?
Here's his colors.
I do it.
What is that?
Really neat, Connor.
No.
My vote is yes. Yeah.
Yeah, can we throw in a.
Don't vote.
Sorry. Doing it all of that. Was that parents?
That was 3 yes, not 3
Me gusta mucho.
The village is against you in this matter.
I don't even know what we were talking about. I was zoned out doing these. I think I was on autopilot a little bit.
Now, another thing you need to be aware of as you're doing these, and I'm going to kind of call Chase out here. I don't know if you're trying to do these on your calculator. Okay. Normally when you're graphing things on your calculator, the scale of the axes goes by ones, or you tell it to go by something else. These, notice every one of those boxes is pi over 2. So that means every one of these boxes is going to be like 1.55-ish wide. And your calculator, this is the important part, just like it will not do simplified radicals for you, your calculator will not work in terms of pi on the graph. Now, if you're good, you can force it to work in terms of pi by inputting it that way, but it's still going to give you decimals everywhere. Additionally, we are doing sine of things in radians. I would need to make sure that when I graph these, not only do I have to change my axes to go by pi over 2 increments, but I have to make sure that I'm in radians. So I could graph these on the same axes. I would have to reset the whole thing to make sure that I'm in radians. Yeah. I go to y equals, I would do, I don't know, what was it, cosine of x and 1/3 cosine of x. But then my window, I would manually have to change my x-axis to go from -2 pi and watch it switch everything over to decimals. 2 pi going by pi over 2 increments. I would need my y-axis to go from, I don't know, -1 to 1 going by 1/3 increments. And then it'll show me everything just fine. But I had to put everything in terms of pi, be in radians, and now when I go back to my window, it's not going to show me anything with pi, it's going to have decimals all over the place. Nope. Unfortunately, we're rocking nearly the same technology we were 25 years ago. Now, there is the tech to do that, it's just they're terrified of putting more stuff on here because TI and Casio are hand in hand with the testing companies. It's all about money. So, we're going to go from -2 pi, -3 pi over 2, -pi, -pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi, no kitty, my pi, and pink. All right, if I'm doing the cosine graphs, I need to go up to 1, and I need to go down to 1/3. You can change this however you want. Do you want to go off-road? Do you want to go off-road so that you're at 1/3, 2/3, 1? Do you want to, what if I just put another tick mark in here and here, and then made those go by 1/3? That could work too, where this is 1/3, 2/3, 1. 1/3, 2/3, -1. Okay? So whether you're going off-road or whether you're breaking up the boxes, enough that you can see both 1 and 1/3, and they're going to do the same dance every time, make big. Cosine starts at 1. I said make big. And then 0, -1, 0, 1, 0, -1, 0, 1. Connect the dots between them, try to keep it curvy. Versus switch to green, 1/3 is just going to take all of those dots and move them down like that. Okay. So, boop. All right. Now, that was showing 1 versus a compression of 1/3. Doop. Doop. If I'm going to switch over to sine of x, you know what? Mop, mop, mop. Oh, see, now you went and did that. Screw you, Frank. All right. Oh, here's another thing. I know that some of you just despise writing in your graph. Like when we did our polynomials, writing the extrema on the graph itself just bothered the living snot out of you. And I had said you could put like point A, point B, and then off to the side write your extrema. What about, since this is my horizontal axis, doing this? Like that. Would that be okay? Would you still be able to tell where everything is though? Okay. Vertical axis. I need to go to 1 and I need to go to 5. Again, I can go off-road, or what if I break this up, there. Because now I have 5 tick marks. 1, 2, 3, 4, 5. Okay? If I do that, then off to the side I can write 5, 1, 0, -1, -5. And then go make my dots. Sine starts at 0. The sine of 0 is 0. And then I will go to 1, 0, -1, 0. -1, 0, 1, 0. Connect dots. Versus 5 sine of x means all that same stuff except dot, dot. We're going all the way up to +5 and down to -5. Connect dots. Like this. Okay? So, we okay with graphing these thus far? Said it's just label your axes, connect the dots with that up, middle, down, middle dance. Okay? Oh, we're doing sine, cosine, tangent, cosecant, secant, and cotangent. We're going to do inverse trig functions. We're going to start changing the period. We're going to have phase shift and period change. That's when we start getting funky fractions. How about the next 48 hours?
What?
Okay. What is going to change when I go from cosine to -3 cosine? I'm hearing us go off-road. Do you see anything with the X? Anything in the grouping of X? Remember, there's an invisible set of parentheses right here. Okay? Since there's nothing in there, there's nothing that's going to change my phase shift or my period. Those are going to be horizontal translations and dilations. So I can put the same junk on there. Negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi, no kidding, my pi, and the amplitudes. Wait. Okay, I need to go up and down to as much as 3. I can either take that and go a little bit off-road, or I can break up the boxes. I think last time I broke up the boxes with 1/3, so maybe this time I'll go off-road for 3 just so you can see the difference in them. I will label accordingly, yeller? Yeah, yeller. We'll call that 0, 1, 2, 3, negative 1, negative 2, negative 3. And cosine. Cosine of 0 is? Uno. And then middle down, middle up, middle down, middle up. Okay, it's going to follow those quadrantal values of x-intercepts and maximum minimums. Middle down, middle up. Middle down, middle up. Now, I'm not just doing this because it looks okay. Remember, the cosine of pi over 2 is 0. The cosine of negative 2 pi is 1. I'm graphing the values. What you're effectively doing here is graphing by table. It's just the table is in your head as you're looking at the unit circle. I connect the dots. And careful what changes for round 2. Because I have a negative 3 in front of it, instead of starting at positive 1, I go down to negative 3 and then continue the dance. We'll start down here, but then, since the cosine of pi over 2 is 0, and I take that times negative 3, I still get 0. Since the cosine of pi is normally negative 1, now it's positive 3. 0, 3. Okay? And then 0, up, middle, down. Connect the dots, try to keep it curvy. And now, I come around and see how many of us got nice curvy graphs.
Look at my graph. I'm very curvy. Get away from my graph.
Don't look at that.
Hides graph in shame.
Look at my graph.
Okay, seeing all them pretty colors. Okay. So, if I have a reflection, it's pretty simple. It just changes which direction we're headed. If this was sine, I could take this entire graph and say if this is sine, it would just be over there, minus dots, okay? But they would start at 0, go up, down like normal sine. Sine would then head downward instead, okay? Yeah, Frank's old. I feel Frank's pain. Go! Those two, one of them has a compression, the other has a stretch. They are both types of dilations. They both have a reflection. That's why I said it might not be a bad idea to write your labels of your axes above or below or off to the side. Because otherwise it gets kind of cluttered on a tiny space. Again, I made these notes years ago. I'm definitely going to update things with larger graph space in the future. I mean, it doesn't benefit you at all, but... I'll find that out. When people start calling me back. Most teacher openings don't happen until mid to late April anyway, and then most interviews don't happen until end of April, beginning of May. So I'll figure it out. I'm also SPED licensed. I'm not concerned about finding a job. It's just I need to find the right location. I need to find the right place for my kids.
Ow, my hair. I just want to color my hair. Well, no, I was just and so I ended up putting on, but I don't no one really knows. But I always do my hair out, so I don't like it stuck with the nose.
Yours doesn't look like that?
Yeah, I do. Yours looks like this. Are we doing both?
Yeah. Okay, contestant 1, my x-axis is labeled as normal. My y-axis, the larger of the two amplitudes, is 1, so I need to make sure that I have up to 1 and -1 away from the midline. And I can nicely break those boxes up to show 1/5 increments to get the other one. Oh, that's right. I can't do that.
Me? I do, but it's like the.
Is it? Oh, it's 99. Yes. Because it's not for my job, it's just for my use.
Oh.
Wait, I'm doing it on the Yes. I don't remember which side.
How come mine is weird? Oh, that's wrong. Yeah, it is. No, it's not.
Is it? Or is
I
it?
keep bringing up the negative.
McDonald's.
There.
Oh my god. Oh.
Are we done with both of these?
No, because it's stupid negative.
Okay.
I did the first.
Okay. There's regular cosine of x. How do I change it for negative 1/5 cosine of x? And? Boop. Connect dots. Like this. Because cosine normally starts at 1, or I should say cosine normally starts at the maximum. With a reflection, it means it'll start with a minimum and then move from there. Okay. That idea of maximums become minimums, x-intercepts become asymptotes. Later, when we deal with reciprocals, is going to help us to define our other functions. Okay. If I switch over to sine of x, boop, 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 boop. Okay, sine of x normally starts at, oh wait, this goes to 4, so I should probably just get rid of everything. Negative 2 pi, negative pi, 0, pi, 2 pi, 0, 2, 4, negative 2, negative 4. Okay, if I label partially like this every other box, can we still tell what is in between? In between 0 and pi should be pi over 2. In between 0 and 2 should be 1. So if I'm dealing with regular sine of x, sine normally starts at 0. Sine of 0 is 0. Sine of pi over 2 is 1. Is 0. Is negative 1. Is 0. Getting middle, up, middle, down. So there's sine of x. How do I change it? Okay, I'm still going to start with 0 because sine of 0 is 0, but instead of going up to the maximum, I will now go down to the minimum. Middle, up, middle, up, middle, down, middle. No.
You don't have your big dog.
It kind of looks like an evil mouse. Yeah, let's not.
What did you say?
Let's remove head from rectum and never say that again.
I think she should get a point for that.
I haven't thought on that.
I think the girls should have a day.
Y'all, are we okay with this so far?
Yes.
All right.
Easy to think now.
All right.
I just always mess up when I use.
What changes when I start messing with B and C is the period and the phase shift. Remember when I was dealing with y equals a times f of b by x minus h? Remember all that business, right? So B was what? What kind of transformation? Horizontal stretches and compressions, and it's always by the reciprocal. Think about if I'm saving up for a car, and all of a sudden, your rich gunkle says he's going to double whatever it is. He's going to put in whatever you're saving up, he's going to match it. Okay? If you double your input, doesn't that make your goal get half as far away? So it always has a reciprocal effect on the outputs. Now we're going to do that, but we're doing it with these curves. So instead of going pi over 2, pi, 3 pi over 2, 2 pi, maybe it gets squished and it goes to pi over 6, pi over 3, and then on and on and on. Okay, you're going to start getting some funky fractions. This is where kids like, oh, hey, this is fine. And then I start messing with the period and the phase shift, and you have to do fractions in terms of pi, and kids freak out. Okay? It's just fractions. Just throw a pi on top. Okay? So we're going to change the period and the period to begin with, then we'll go to phase shift. Also, difference in definitions here. The period is how long it takes to complete one full cycle. Well, they're just showing any 2 points. Because now I can show you that it's also those 2 points. That it's also those 2 points. That it's also those 2 points. Okay? Anywhere I start to repeat myself, that is the next period, the next cycle, the next iteration. A period is how long does it take to repeat itself, to complete the cycle. Frequency, on the other hand, is how long or how many cycles do you have within a given space. So like, in this space, how many times did it repeat itself? From here to here, how many times has this repeated itself? So maximum, minimum, restart. Maximum, minimum, restart. Maximum never got to the minimum. So there were 2.5 cycles within this space. So its frequency is how many cycles were in this space. Now normally, I would just say 2 pi over b is period, and then b over 2 pi is frequency. How long until I complete a cycle? How many cycles are completed within that space? Sine or cosine works here. That. Okay? So B, the same thing that it was when we were doing any other function transformation, but now they're not going to separate it from the x minus h for us. Okay? That's why when we do phase shift, we're going to have to do a little bit of division. It's literally just negative c over b. It's not a big deal. Okay? So period is how long or what space to complete a cycle. Frequency is how many cycles in that space. And you can always reduce these. In fact, you have to reduce them. So, we have the cosine of x and the cosine of x over 3. We'll do regular y is cosine of x, and we'll do y is cosine of x over 3. So the first step to this is identifying what the b term is. What number is in front of x? 1. So the period is going to be 2 pi over b, which is 1. Okay, it's just 2 pi. That's no big deal, though we were just doing those. Now the next one, the period is 2 pi over b. Careful. What is the number in front of x? Not 1. 1/3. Right? Because x over 3 is 1/3 x. Pi over b becomes 6 pi. Because it's not the same thing. It isn't over 3, it's over 1/3. To complete a full cycle. Dividing by fractions is easy as pi. Okay. So, just like last time when I was changing the amplitude, I had to make sure that my scale fit both of them. This wants to do a minimum of 2 periods of each function on the same set of axes. So I need to have an x-axis that covers both of these. So which one's bigger? 6 pi. So I'm going to go from 0 out to 6 pi now, and negative 6 pi. Remember that those maximums and intercepts and minimums, they always happen at 1/4 of the period. So I have never seen a textbook use these, define these, give them a vocabulary term, or in any way, shape, or form reference them. They just assume you know. I call them just the quarter marks so that I know we have a shared vocabulary. My quarter marks for this, where those relevant features are going to happen, take this times 1/4, and my quarter marks are going to be at 6 pi over 4, or what? 3 pi over 2 increments. Right? If I take 0 to 6 pi and I break it into 4 pieces, each one of those pieces is 3 pi over 2. Another 3 pi over 2 is 6 pi over 2, reduce it. 9 pi over 2. 12 pi over 2, and reduced. Do you see how that is the same as over here? If I would take 2 pi times 1/4, I swear that's a 4, I would get pi over 2 increments. That's what we've been dealing with already. All of our boxes were pi over 2s. Well, this has a bigger period, so it needs bigger quarter marks. I'm going to go do the negative versions of those. Negative 3 pi over 2, negative 3 pi, negative 9 pi over 2. So I'm going to graph this guy first, and then hopefully you'll see why this can get weird. What's the amplitude on both these? 1. Do you want to go up to one box or do you want to go up two boxes so the graph's a little bigger? Two boxes? Okay. So I'm going to put 0, 1, -1 there. All right. And then I just do the dance. This guy is cosine. Cosine starts at midline or maximum. Normally starts at the maximum. No, it does. It's just instead of repeating itself when it hits 2 pi, now it's not going to repeat itself till it hits 6 pi. I still do the same dance. Because if I put 3 pi over 2 in here, 3 pi over 2 divided by 3 is pi over 2. What's cosine of pi over 2? 0. It's the same dance. I just labeled the axis to make it work for me. And I go to -1 and 0 and 1. And 0 and -1 and 0 and 1. Yes, it's going to be W every time it's cosine. Okay. Right now, my x-axis is broken up, so every one of those boxes is 3 pi over 2. But the OG over here says, no, I need dots every pi over 2. How do I alter this to show pi over 2 increments somewhere? Not halfway. In between each of them, how many pi over 2s go into 3 pi over 2? 3 of them. I need to break each of these boxes up into 3 sections. So, from 0 to 3 pi over 2, I'm going to say 1 pi over 2, 2 pi over 2, 3 pi over 2. 1/3 of the way, 2/3 of the way, there. 1/3 of the way, 2/3 of the way, there. 1/3 of the way, 2/3 of the way, there. Now, from 0 to 3 pi over 2, I have 3 sections. So each section must be worth pi over 2. Poke, 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 poke. I'm still going to graph this. It's the same amplitude. At every one of these tick marks, I have my up, middle, down, middle. I need everyone to be with us before I start drawing because otherwise, oof. Okay? Remember, I have changed the period. The period and the frequency changing means in this space, I have this one period in each direction. How many of these fit in this space? So this whole graph is going to show 1 of these. It's going to show 3 of these. That's why I said a minimum of 2 periods of each. I'm okay with that because otherwise it's going to be so nasty. Yeah? It depends on the dance. There are times when they're going to overlap. So I will still start here. But watch what happens as I go every tick mark. I start at the maximum and then we go to 0 and then the minimum, right? Here's 0. Here's the minimum. Here's 0. Here's the maximum. Here's 0. Here's the minimum. So they will overlap at some point because 3 of these fit in one of those. Middle up, middle, down, middle, up, middle, down, middle, up, middle, down, middle, up, middle, down, middle, up. And when I go to connect the dots, and I will see 3 of these per one of those.
Why aren't mine overlapping right there? Maybe like a tick.
Oh, okay, I don't like how that looks.
Because you missed middle.
No.
Middle,
Oh.
up, middle.
Okay.
Putting 2 of them on the same set of axes. Okay. Putting 2 of them on the same set of axes can be difficult. Yeah, technically it's got the arrows because it keeps going. Now, if you want to deal with equations and identities of these, that's trig. That's the next class. Our chapter 5, I don't do because you do it in Spears' room. Okay?
What if you had the X on mine?
We won't.
Wanna try it? So then you have like the domain and everything.
Mm-hmm.
No shot.
Okay. So, putting them on the same set of axes is tough. Sometimes. It depends whether those quarter marks line up or not. If they've got common denominators, everything's great. If they don't have common denominators, things get nasty. So that was a cosine. There's a sine, there's a cosine, there's a... You know what? Let's just do... Do 3A and B, because I'm going to mess with C.
Right.
Do you want to do the tough stuff in here when you have practice and you can talk through it, or on your own? It doesn't work that way. Yes.
Is that right for the quarter thingies?
So,
Pi and 3 pi?
pi over 2 for this one.
Yeah. No, for like the first one.
This guy.
No, for this one I meant, sorry.
This guy?
Yeah.
4 pi, so quarter marks are at pi. Yes.
Okay.
Wait. Yeah. That's fine. Silly. Okay. Wait. So it's.
So first you identify what b is, 2 pi over b to get the period, times 1/4 to find where your quarter marks are going to be. But if you plug in a pi, now it's pi over 2. So at pi, you're not going to see -1, you're going to see 0. You are going to have all the colors, yes.
Okay, so if I go 0, then pi.
Mm-hmm.
And the cosine at pi.
No. You're plugging pi in here. You are graphing this one right now. It still goes maximum, midline, minimum, midline, maximum. Because when you plug pi, 2 pi, 3 pi, and 4 pi into here, you're going to get pi over 2, pi, 3 pi over 2, and 2 pi.
So this doesn't make sense then. I'm lost because I have 0, and at 0, it's at 1, right?
Mm-hmm.
Yeah.
Why?
Because 0 divided by 2 is 0. Cosine of 0 is still 1.
So I'm taking the cosine of pi over 2, really. So that's.
That makes sense.
Got it! Okay. So, first one, just to make sure we're all on the same track. Pi over b for both of them. Quarter marks of both of them, I'll get a period of 2 pi versus 4 pi. Quarter marks of pi over 2 versus pi. If I want them on the same set of axes, I need to go to the larger period. I'm going to go from 0 to 4 pi to -4 pi. Fill in the marks by pi increments. -3 pi, -2 pi, -pi, 0 pi, 2 pi, 3 pi, 4 pi, no kidding, my pi. And and there we go. The amplitude is still 1. Just so you see the difference, I'm going to go to only 1 box this time. I know some of you are still going 2 boxes. I'm just going to 1 so we can see the difference. Cosine starts at maximum and then continue the dance. Middle down, middle up. Middle down, middle up. Because if I put pi in here, I'm now taking cosine of pi over 2. If I put 2 pi in here, I'm now taking cosine of pi. Okay, so I'm plugging those values in and getting the same results. Connect the dots, keep it curvy. What needs to change for the OG? Right smack in between them is pi over 2 increments. So here, 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 here. And now when I do my up, middle, down, middle dance, I just have to watch those lines, those marks. So I still start with the maximum because cosine of 0 is still 0, but then cosine of pi over 2 is 0. Cosine of pi is -1. Is 0, is 1, is 0, is -1, is 0, is 1. Middle down, middle up, middle down, middle up. Connect the dots. and they just look really cool. I feel like Marge Simpson holding the potato when I say that. I just think they're neat. Okay. So this was part A, just the cosine stuff. Okay. Are we cool with part A? Go on to part B. Would you be able to do this if I tossed a negative in front of it? That means you would make one of them, and then the other one would be flipped. Okay? Sine and sine of 3x.
Why is this paper like soft? A normal. Oh. Sorry. I don't have here. Wait. Oh my god, so good.
Oh, 3 was there.
It's smart. So, oh my goodness. How do you get them to be highlighted?
Oh, wait. That whole one's wrong. No.
No.
Right.
I have allergies. The same. I don't know. I feel like allergies.
Wait, I did it right.
What does
Just your-
What?
I hope you did Chris.
is it?
No, I had it right.
So how did you get it from high over 6? You did have it high over 2. That's just like,
Because there's 3 of these and 1 of these.
you guys. Okay.
So I broke each of those chunks up into thirds.
Wait, I like it when I make it. I like mine because then I know what I like. This guy's So this is the bigger one.
It's the bigger one.
I gave you that. I already told you.
Ruh-roh.
I need you just. What if I go? I just don't know.
This has the larger period, so I'm going to go to negative 2 pi and 2 pi respectively. I need to fit this one in here because it's a smaller one. Pi over 6 increments go into pi over 2 increments 3 times. So that means I just need to break each of these up into thirds. So contestant 1 gets to be regular old sine. But contestant 2 has to be mindful of those pi over 6 increments instead. So up, middle, down, middle. Up, middle, down, middle. There we go. That was right. Yeah. I just hadn't written my quarters yet, and that messed me up. Say again.
Like this, like not the dots, because the dots confuse me when I have to like draw them out.
So long as it's accurate. If you don't use the dots, most kids will accidentally miss a portion, left or right. If you can do it, go for it. I'm saying, I know I screw up every time I don't do dots. Literally every time.
So if I can't like calculate.
That's a very valid.
No. Orange.
Is it
This goes for the next 2 weeks. That is comment section, so that's one where you have to square. I will like that.